I have discussed with you in detail about discrete time signals, convolution with regards to discrete time signals. It is the same or almost similar to in the case of continuous time signals. For example, in discrete time signal, I told you xn is what? Xn is equal to, it is summation of x equal to k equal to minus infinity to infinity, xk, and then del n minus k. This you know. Similarly, in case of continuous time signals, xt, it is given as minus infinity to infinity, is integration from minus infinity to infinity. The way we use k here we use tau. So it is like this, x tau into del t minus tau d tau. This is x. Okay. So in this way, we can express ut as integrating from here to here, not u, impulse function t minus tau d tau. Okay. So finally, if we say there are two signals x and h is the response, then yt is convolution of xt and ht. Why? This I have already explained when I was explaining discrete signal. There we use summation. Here what we'll use? We'll use integration. So this becomes x tau h t minus tau d tau. Clear? So these are the simple formulae in case of continuous signals. Everything I have explained when I was explaining discrete signals. Now let's see example and understand how we find convolution of two signals. Our signal is xt is e to the power minus at, where a is greater than 0. It is a positive number, and ut. Okay, ut means this signal is from 0 and onwards only, that is greater than 0 only. Below 0 it is 0, and this is st, which is ut. Simple. So try to understand this. What are these signals? I am plotting them here. First is your xt. What is xt signal? Below this it is 0. It will be maximum. What will be the maximum value of this signal at t equal to 0? T equal to 0, it will be 1. So this is 1, and then it decreases exponentially. This is your xt signal. Okay. What is, let's say we are talking on tau, so x tau. What is h tau? H tau is simple, this. Clear? Then what is ht minus tau? See, h tau you write like this. It is equal to 1 for tau greater than 0 and 0 elsewhere. Alright. This is the definition. So if you put like this, ht minus tau, what it will be? It will be again 1 and 0. Where? 1 at t minus tau greater than 0, and otherwise it is 0. What is the meaning of this? This means this goes to this side. It will be tau will be less than t. This means tau less than equal to t. So it is 1 only when tau is less than equal to t. Therefore, and similarly this thing, tau less than t. What if t is minus? T is minus, you know how to shifting and scaling. So this becomes, if this is the signal, if t is less than 0, this will be like this, and if it is greater than 0, if t is greater than 0, it will be like this. Clear? This is t, the scale is tau. Okay. Now think of this signal xt in xt ht minus tau. Think of this. It is 1 only for less than t, and this signal is applicable only for, and this is tau, x tau, ht minus tau. This is only for greater than 0, where tau is greater than 0. That is, this puts the condition tau should be greater than 0, and this puts the condition tau should be less than t. Okay. So your value will lie between, tau will lie between 0 and t. Okay. So your integration minus infinity to infinity becomes, the limits will be 0 to t. Clear? So now let's do convolution. Yt is minus infinity to infinity x tau into h t minus tau d tau. This is the definition. We saw the limits will now become 0 to t. This is x tau. X tau is what? E to the power minus a tau. Ut means this belongs to 0, greater than 0 only, that is ut. And then ht minus tau. This ht minus tau becomes ut minus tau d tau. Now this limit has put this, so this also gone. Now what is integration of this? This means minus 1 by a out, so it will become minus a tau 0 to t. So what is this? This is minus 1 by a e to the power minus a t minus 1, or you can say it is equal to 1 by a 1 minus e to the power a t. This is your signal. But we know the limits are only limits have we have limit that this should be greater than 0, so you can put ut here to identify that this is possible, or this signal is valid only for t greater than 0. So this is your final answer. If you want to plot it, what it will be? See, at t equal to 0, what will be the value? When t is 0, this is 1, so this becomes 0, so it is here. And at t equal to infinity, this becomes 0, so this will be 1 by a. That is, at t equal to infinity, its value will be 1 by a. This is your yt. So the signal will be like this. You know this signal, you have used this signal many a times. So this is plotting of the signal. Okay, let's see one more example. This is our question. Xt is this, t plus 1 between 0 and 1, when t is between 0 and 1. It is 2 minus t when t is between 1 and 2, and otherwise it is 0. And ht is, it is a combination of two impulse functions, del t plus 2 plus 2 del t plus 1. So let's find convolution. Yt is equal to, it will be minus infinity to infinity x tau h t minus tau d tau. Okay, so this is minus infinity to infinity x tau h t minus tau. So let's put this signal. It will be del, it is t plus 2, so this is t plus 2 minus tau, then it is 2 del t plus 1, sorry, t plus 1 minus tau d tau. Okay, now separate them. This will be minus infinity to infinity x tau del t plus 2 minus tau d tau. This is the first one, plus twice minus infinity to infinity x tau del t plus 1 minus tau d tau. Okay, these are the two signals. Now if you remember, we say that xt is equal to what? It is equal to minus infinity to infinity x tau del t minus tau d tau. This is the definition. So using this definition, what is the meaning of this? See, this is t minus tau, so this is this. So this means xt plus 2, these are continuous signals. So xt plus 2, then plus 2 xt plus 1. So we have got our signal. This is our signal. Now we'll resolve it into this form. Okay, so let's analyze the first signal, xt plus 2. What it will be? See, you have that signal, so this will put t plus 2 plus 1, and the limits will become 0, t plus 2, 1. Then it is 2 minus 2. So 2 minus, we have t plus 2. The limits are 1, t plus 2, okay, and then 0 elsewhere. Let's understand this signal. This is now what? T plus 2 plus 1. So this means t plus 3. This is 2 minus t minus 2. So 2 minus 2, 0. So this is minus t. And this is 0. T plus 2. This means if you put minus 2, minus 2, minus 2, what it becomes? 1 minus 2 will be 1 minus 2, minus 2, minus 2. So what you get? You get minus 2 to minus 1. Minus 2 to minus 1. This is the limit. Here 1 minus 2. So minus 1, and this is 0. So minus 1 to 0 and 0 elsewhere. So xt plus 2 means this. Okay, let me write it here. xt plus 2 means t plus 3, and the limits are t to minus 1. Then you have minus t, minus 1 t, and then 0 elsewhere. This is your xt plus 2. Let's see the second signal, xt plus 1. So t plus 1 and here t plus 1. So this becomes t plus 2. The limits will be, I'm expanding. This is the original limit. So we'll put t plus 1 here. Then what you have to do, minus 1 here and minus 1 0. So this becomes minus 1, this becomes 0 if you take t. Okay, so the limits are between minus 1 and 0. Second is 2 minus t. So 2 minus t plus 1. This means 2 minus t minus 1. What is it? It is 1 minus t. So 1 minus t. The limits will be, this is, so we have t plus 1. So minus 1, this becomes 0, minus 1, this becomes 1. So 0 to 1. Okay. And then 0 elsewhere. So 0 elsewhere. So this is the second signal. I am writing it where? So I am writing it here. Xt plus 1 is, or I am taking directly twice xt plus 1 because we have twice xt plus 1. This will be twice t plus 4. So 2t plus 4. The limits are minus 1 to 0. Minus 1, 0. Then 2 minus 2t. 2 minus 2t. The limits are 0 to 1. And then 0 elsewhere. Okay. So these are two signals. What is yt? Yt is combination of this, linear combination of this plus this, this plus this. So our limits now will be, see, minus 2 to minus 1. Then here we don't have any conflict. Minus 1 to 0. See, minus 1 to 0 we'll have to add this and this. Then we'll have this one. And then a third one, 0 elsewhere. So this becomes, I'm writing like this. See, from minus 2 to minus 1. Let's go up to this limit. We don't have any conflict in these two signals, so the signal will be t plus 3. Okay. Now let's take from minus 1 to 0. Minus 1 to 0, it will be this minus t, and then minus 1 to 0, it is this. So it is minus t plus 2t plus 4. This is the signal. So 2t minus t, it becomes t. So it is t plus 4. Then third limit is, here we have, this one is 0, but see, 0 to 1 we have, from 0 to 1 we have 2 minus 2t, and then elsewhere we'll have 0. So this is our final signal. Yt will be t plus 3, between this, then t plus 4, this, then 2 minus 2t, and then 0 elsewhere. So if you plot it, what it will be like? See, from minus 2 to minus 1, then 0, and then up to 1. We have the signal between minus 2 to 1 only, otherwise it is 0. So minus 2 to minus 1, it is t plus 3. T means 45 degree, and t, it will reach this 3. So if it is 1, 2, 3, 4, because we have 4 also. So t plus 3 means this. This will be, so at t equal to minus 2. At t equal to minus 2, this will be 1. So let's say this is 1. At t equal to minus 1, it will be, what will be the value? If you put minus 1 here, it will be 2. But you see, when it is minus 1, it actually is 3. And this is also, this also shows that this will go up to 3. So this, it will follow this line. So from here to here, it will be like this. Okay. Then at this minus 1, it is this one. At 0, it will be 4. So simple, from here to here, it will go to 4. This is 4, this is 3, this is 2, 1. Okay. And then 0 to 1, it is 2 minus 2t. Minus 2 means the slope is like this. And from 2, it will start from 2. So it is like this, here to here. And then it will be like this. Okay. So your signal is, I'm taking another color, your signal is like this. This, 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 this. Okay, this is t and this is yt. Clear?